the white since stationary process is defined as xt if is WSS if its expected value is constant and its articulation depends on T1 minus T2 only. So it's according to its definition, we can judge we can judge a process that if it is WSS based on the mean and autocorrelation, we can easily get the also through the mean and autocorrelation, we can get the average power of the singular T1. In addition, if the input to a LTI system is WSS processing, the output is also WSS. About the independent increment process, it defined as if two interview has no two-time interview is non-overlapping, then we can think they are independent. It defined as the probability as it shows here, and we can know Poisson process and the random walk and Wiener process are independent increment process. And Markov process, we see that process xt is a Markov process of the past has no influence on the statistic of the future under the condition the present is known. So it just like the memoryless system. Its present value, its future's value only depends on its present value. The past value has no influence on the future's value. So we can know that the semi-random telegraph singular, the Poisson process, random telephone singular, and random walk and the Wiener are Markov process. A Markov process is a statically determined if one node is second-order distribution function. And a normal process, xt is said to be normal if the random variable xt1, xt2, xtn goes to xtn are jointly normal for any t1, t2 goes to tn. That is it, right? As it shows here, and we can know that a normal process is only determined in terms of the mean epsilon t and the autocorrelation. So we can know that the Wiener process is one example of normal process. About the strict scintillation process, a process is said to be a strict stationary process if it is static is not affected by a shift on the time x. So if we shift the time, we add the epsilon about the time of the input. There will no change for the input if we shift the time t1 to t2. So the outcomes of the of this process is not it does nothing about time. So we also can know that if a process is SSS process, we can know that the mean is a constant and the autocorrelation is a function about tau, about t1 minus t2. Okay, about the Wiener white noise. White noise is a stochastic Vt is said to be a white noise if the mean of Vt is 0 and the autocorrelation is Qt1 delta T1 minus T2. So Vt is a white noise if it satisfies this function, and we can know that the omega t the differential with t of t is a Gauss white noise, where omega t is a linear process. So, and if the input to a linear system is a white noise with the Rx, with this, we can know that the average power, we can get the average power as it shows here. Also, ZT minus lambda is also white noise. And about the stochastic process, xt is also said to be mean equatic process if the name, if it is satisfied, when t goes to infinity, the interval of xt from minus dt to over 2t equal to the mean of xt in mean square sense. Or we also can get that we also can write it in other form about the autocorrelation, autocovariance, and ext, the mean of xt must be a constant that we can know, and the mean square sense means that when t means that this. So that's all.